Well, hello and welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and serving the over 100,000 computing professionals and students who are ACM's members. I'm Matt Grad. I'm a marketing manager here at Continuum Analytics. For those of you who may be unfamiliar with ACM or what it has to offer, the ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see some of the highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. ACM provides timely computing information published by ACM, including Communications of the ACM and Q magazines, access to the ACM Digital Library, the world's most comprehensive database of computing literature, international conferences that draw leading experts on a broad spectrum of computing topics, and support for education and research, including curriculum development, teacher training, the ACM Turing, and ACM Infosys Foundation Awards. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Before we get started, I'd like to quickly mention a few housekeeping items shown on the slides in front of you. First, the slides will advance automatically throughout the event. On the bottom panel, you will find a number of additional widgets and resources. If you are experiencing problems with the slides or audio, press the F5 key in Windows, Command R if you're on a Mac, or refresh your browser on a mobile device. Or you can close and relaunch the presentation. To control volume, adjust the master volume on your computer. If you have questions during this webinar, please type them during the Q&A box at any time during the webinar and click the Submit button. I'll organize the questions as Christine Doig speaks, and she'll reserve time at the end of the presentation to address them. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. And please check learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute to fill it out to help us improve our webinars. You may also open the survey at any time throughout the presentation from the menu dock at the bottom of your screen. You can also use the Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag ACMLearning. We'll be watching for your tweets. Today's presentation is Embracing Open Data Science in Your Organization by Christine Doig. Christine is a senior data scientist at Continuum Analytics, where she has worked on, amongst other projects, MEMX, a DARPA-funded project helping stop human trafficking. She has more than 5 years of experience in analytics, operation research, and machine learning in a variety of industries, including energy, manufacturing, and banking. Christine holds a master's degree in industrial engineering from the Polytechnic University of Catalonia in Barcelona, and she loves empowering people through open source technologies and is a regular speaker and trainer at community conferences including PyCon, EuroPython, PyData, OSCON, and Data Science Summit. And now, Christine, without further ado, please take it away.
Thank you, Matt. So today I have the following agenda. We're going to start with an introduction to data science for those who are not familiar with the field. We're also going to take a look at what are the challenges that organizations are facing when introducing data science teams and wanting to embrace open data science in their organization. Then we're going to move into Anaconda distribution provided by Continuum Analytics, which is a free Python distribution and R distribution for open data science. And finally, we're going to take a look on what are the projects that the Anaconda Community Innovation Team is developing to enrich the ecosystem, as well as just a couple of ending slides on the enterprise platform and how are we helping our enterprise customers embrace open data science. So let's start with the introduction to data science. If you're familiar, if you've been following this field recently, you're probably familiar with this Venn diagram that tries to describe what data science is. And we can see how this Venn diagram shows that it's a combination on hacking skills, on computer science skills, math and statistics knowledge, and then some kind of substantive expertise in an area that you can apply those skills to. Here at Continuum Analytics, we often like to rethink that Venn diagram in another way, and looking at data science as this emerging field that is actually taking advantage of what other fields have been doing for a long time and bringing it together. So there's been machine learning research has been done for a long time. There's a lot of work being done in academia. But then like the combination of all these different systems, machine learning, visualization, traditional analytics, computer science, high performance computing in the scientific community, and then the technologies that have been developed in the big data world, they're all coming together to solve commonly big data, data problems, including large scale. So how this, came into the industry. We can take a look that before, nowadays we can find a lot of data science boot camps, master programs, PhD programs in data science. All the universities are starting kind of their programs that mostly take, old, statistics and machine learning, computing teams and reorganizing it through this new paradigm that we're defining as data science. So before that happened, in the last 4 or 5 years, we already had data science, like what skills did data scientists bring to the enterprise industry? So we can see that people come with a variety of backgrounds. So you might have traditional statisticians, analysts that have evolved to becoming data scientists. People that were more in the scientific computing world doing research, computational science, and then developer engineers that were ended up doing more data science because of the place they were in their job, and that they needed to scale and then add some analytics to those large data sets. So each of those types of data scientists come with a bag of skills that they're familiar and used to. And the statistics, SAS, R, Excel in the analyst world has been popular. People coming from a computational scientist background, they might have been using MATLAB, Fortran, and developers, engineers might use Java and C and C++ languages. So something that we in Continuum Analytics have observed is how Python really has become this language that cross, multiple people's skill sets for its ease of learn, very English syntax, very readable, and that has a lot of power. It has a big ecosystem that can fulfill the needs of those 3 different types of data scientists with their different backgrounds. So it's not, it's been observed in this industry how Python is becoming the most popular language in data science. Of course, we still have R. There are new languages like Julia and Clojure and Scala that have also are also still being used in like the data science community. But Python is really making a lot of progress in becoming kind of the leading data science language because of extensibility and the capabilities that goes across not just having machine learning libraries, but also being a full programming language where you can also develop web applications with. So just a brief summary of what we've observed. So data science is a team sport formed by team members that have a very diverse backgrounds, both in terms of knowledge, computer science, statistics, visualization, machine learning, and technology stacks, including R, SAS, and Python. So kind of like the questions that we have is how can companies organize efficiently in this type of environment? So what companies need is an inclusive movement that makes open source tools for data science, data analytics, and computation easily work together as a connected ecosystem. And that's what here at Continuum Analytics we define as open data science. The open data science community is vibrant and growing. We have 30 million Python users, over 16 million R users, and there's over 720 packages in Anaconda. And we know that in big data technologies like Spark, we have over 50% of Python usage. In the Anaconda community itself, we already have over 3 million downloads, and that was as of December 2015. We know that we have, almost another 3 million just added to this year to date. So it's a very growing community. A lot of people are embracing it. And they're doing that because with open data science, you get the availability. Everyone, everywhere can start learning how to use the platform. It triggers innovation. Closed-source solutions can no longer keep up with the innovation that's happening in the open, in this open data science community. It allows for interoperability. Things are thought as how we connect with each other. They're building blocks that build on top of each other. And then you get the transparency of knowing what are you actually running and not just getting a black box. And that's being done for everyone in the data science team. And now we'll take a look of what people form this data science team. So in conclusion, adopting open data science is the foundation to modernizing organizations. So we've mentioned different types of data scientists, but data scientists are not the only player in a data science team. We also have business analysts, traditional analysts, that also explore and analyze data. We have developers that write software packages that can include machine learning algorithms, etc. We have data engineers that worry about the infrastructure on where data lives, how to manage it, and DevOps who can take applications that built on data science components and make sure that those keep running and operating them. So let's take a look on a subset of those different personas and see what types of data science assets they generate. For example, business analysts are probably living in Excel spreadsheets. They tend to write reports or presentations to show insights in the data they manage. Data scientists are familiar with using notebooks for presentation, maybe writing scripts to automate some type of process or building models, and then also showing their work through visualizations, typically a little bit more complex than the ones the business analysts can show. That can include interactive data visualizations through a web browser. And we finally have a developer that can write the software packages or is responsible for deploying web applications that can have a component like, for example, a recommender system like what we see in Amazon that uses part of a data science component, and that developer is the person responsible for making sure that that service, that web application is up and running. So let's take a look a little bit more focused on the data scientist and the data scientist assets. So maybe not all of you are familiar with the notebooks, which has become kind of the data narrative storytelling de facto tool for data scientists. We'll get a little bit in more detail what notebooks are. We can also see interactive data visualizations that they can build and share with other people, so other people can look into more detail or have some control over what they want to see in the data. In this case, we have database of movies explorer, so people can actually filter and query interactively. And then data scientists are also very familiar with writing scripts that can be Python, or in this case, we're looking at some R, snippet, and have kind of this IDE where they write those scripts and run their models, etc. So what they're kind of this is just a simplification of some of the data science workflows that we observe. So we tend to separate the workflows into explore and analyze, collaborate and publish, and deploy and operate. So in explore and analyze, that would be the first step. You have data somewhere, and data scientists and business analysts need to query the data, clean and tidy it, make some prediction simulations or optimize some type of process, visualize the results, And then their outcomes, can be things like, an actual predictive model served through a REST API so that web applications can use it. These interactive applications where people can actually query or observe the outcome of those simulations. The interactive notebooks which tell a story of your data science workflow, maybe some type of presentation or report. Then we have, the work that's being done between the business analyst and the data scientist and developer can be shared, and so that each one can build on someone else's work. So, for example, a developer can build a new software package with an advanced machine learning algorithm that then the data scientist might want to use to build that predictive model, and the results might be in some type of notebook that then is shared with the business analyst so he can make business decisions based on that information. Another big workflow is also that, like, how do you deploy and operate those systems, usually those live systems like in web applications, etc. You typically have like a DevOps person that knows like what infrastructure you have or is responsible for setting that infrastructure, both in like cloud computing or web services, or maybe on-prem, like the on-premise internal clusters, etc. Then you might have a data engineer that is responsible for integrating or making that data available for the data scientists and business analysts to easily access. And you have that developer that is also responsible for making sure that web applications operate well and are deployed, and you have a continuous integration system. So what are some of the challenges organizations face in this, in this setting? So how do you manage reproducible heterogeneous data science environments? Maybe some of your data scientists are using R, maybe others are using Python, some might be using Mac, others Linux. You might have a lot of business analysts using Windows. How we distribute those data science assets and make sure that everyone has access to those, or the right people have access to those, and they can build on top of someone else's work. How we get those data science teams, like between the business analysts, the data scientists, the developers, the DevOps, to collaborate effectively. Even if they're using different languages, tools, data models, they're delivering different assets. Another problem has been how we make data scientists easily leverage big data technologies, which has mostly been managed by more technical people in terms of computer science background and architecture technologies. Making it easy for those data scientists to leverage the data that exists in those technologies and bring those insights in a way that doesn't make them completely break the workflow they're used to. We also need to know how we can deploy these assets that the data scientists generate into production applications like web applications. Another two big challenges: how we make sure that the insights that are shown through like complex machine learning models can be shared with decision makers so they know the consequences of deploying each of the models. And finally, how we also enable those business analysts and managers to be more independent in leveraging the data science work that your team is building, and not, and connecting that gap that currently exists because of the different technical skill sets that it requires to start using those technologies. So in this, the rest of the webinar, I'm going to go through how are we solving those challenges at Continuum Analytics through the Anaconda distribution, the Anaconda Community Innovation Projects, and finally just like a brief summary on what we offer for our enterprise customers as well. So let's take a look at what the Anaconda distribution is. So as I mentioned, the data science ecosystem is bringing together a lot of different fields on analytics, visualization, machine learning, big data, scientific computing, computer science programming. What the Anaconda distribution does is make it very easy for people to get started with data science by providing a distribution that includes those packages. And both supports Python and R. Also, you can use Spark with it, which is a Scala-based, etc. So really making one distribution for data science. We have an amazing community. We have a lot of supporters. I mentioned earlier over 3 million downloads. Probably this year we're already in 6 million if we do the math. So it's really great to see how much adoption we're getting and how many problems we're solving. People that were not able to install or create a data science environment that can actually move across different teams and different languages. So it's free to download Anaconda from our website. So continuum.io downloads. We have support for Windows, OS X, and Linux. You can go through the graphical installer or the command line installer as well. So let's take a closer look at the Anaconda distribution. There are a lot of terms that we use in Anaconda, so it might be a little bit overwhelming on someone completely new to this ecosystem. So the Anaconda distribution is a Python distribution that includes over 150 packages for data science by default in the installer. And that can include things like NumPy, SciPy, Panda, Scikit-learn, the Jupyter Notebook, Numba, Matplotlib, etc. For those people who want more control or might want a lighter weight version of Anaconda, you can also install mini Conda, which is just Python and Conda. And Conda is a package manager. We're going to see more information in the next slide. But that allows you to install your custom packages that you actually need. We also have a cloud service called Anaconda Cloud, where you can host and share public and private packages and notebooks and environments, those data science assets that we've seen previously, and public uploads are free. Finally, the Anaconda Navigator comes with the Anaconda distribution, and it's a UI to help you manage environments, launch applications, and learn about what's happening in the community. So let's take a look. This is what the Anaconda Navigator looks like. So from this UI, you can launch notebooks, you can launch Spider, which is an IDE, or the Orange app, which is a graphical interface for doing machine learning and data mining. You can also manage your environment, see what packages you have in each of the different environments in your system, install, update, remove packages, see what versions you have, etc. And then in the Learning Community tabs, you have a lot of information, videos, materials to learn more about the Anaconda community and how those packages can help you solve your problems. So as I mentioned earlier, Conda is the package manager that comes with Anaconda. And it's a cross-platform and language agnostic. That means that can be used with Windows, Mac, and OS X, and Linux. So if you have a heterogeneous team where different people use different platforms, by adopting Anaconda, they can easily collaborate in that regard. It also supports different languages, both Python, R, as I mentioned earlier, or also we support Spark, and it also helps with environment management. Something interesting that has happened in the Conda adoption by the community is that now there's a Conda Forge community that collects recipes and builds the infrastructure for distribution for the Conda package manager. So it's a community-led effort. Continuum is not directing that effort. They do use Anaconda Cloud as a place to upload those cross-platform packages. And we can see things like, for example, TensorFlow is up there, and other, other packages that might be included in the default Anaconda distribution can now be very easily accessed. We also have Conda environments, which are custom isolated sandboxes to make it very easy to reproduce and share data science projects. So if you have a Conda environment, you can share it with someone, and then they can get exactly the same versions of packages they need. So you avoid a lot of those problems of, updates in packages, and then you don't, you have different versions of Python or different versions of specific library, and then things break from one computer to the other one. You can solve that by using Conda environments. One of our newest projects is called Conda Capsule. And Conda Capsule allows you to do reproducible executable project directories. And you can find a lot of more information about Conda Capsule. It's a way of automating your README, so you can, out of the box, launch an application or launch visualization, and it has all the runtime dependencies needed to execute that. So just some examples, so you can see some code of how Conda works. So once you install Conda, Anaconda, or Mini Conda, you'll get Conda, and you can see examples of how you can install dependencies. So you can install different versions of Python and update all the packages accordingly. You can install Python packages like pandas. You can also install R and R packages. And as I mentioned before, you can also install community-led Conda packages from the Conda Forge channel, like, for example, TensorFlow. How do we manage, to manage multiple environments? Very easy. You can write an environment.yaml file. You specify the name, from what channels you want your packages to be searched. And then you can specify dependencies, and you can have it open to get the latest, or you can actually specify specific versions of like Python or Spark. There's also an example of like the command, like once you have like a capsule file, project.yaml, you can actually run, and that would like deploy an interactive visualization for you with all the runtime dependencies. What challenges does the Anaconda distribution solve for a lot of our users? So it makes it very easy to install on all platforms. As I mentioned, it's language agnostic. It's trusted by industry leaders. A lot of it's BSD licensed, so a lot of industry leaders are using Anaconda as their de facto data science distribution. We have a trusted community, large user base. It's very easy to extend. So if you want to build your own Conda packages, it's open source. It's very easy to build, share, and install any of your proprietary libraries with systems like Anaconda Cloud or your own system that you want to use to share libraries. It allows for these isolated custom sandboxes to handle different versions of packages or languages themselves, like Python 2.7 and 3.5, and also allows for easy encapsulation and deployment of data science assets with the new Conda Capsule project. So let's move into what are we doing besides the Anaconda distribution to help the community, the data science community, innovate and get to the next level. So there are a few projects that I want to mention. We have more than those. But for this amount of time, I wanted to present 4 of our open source projects that we're actively developing. And those are like Introduction to Jupyter for those of you who are not familiar with the notebook, and then present a little bit like Jupyter Lab, which is going to be the next generation of data science IDE. Also present Bokeh for web interactive data visualizations without having to learn any web technologies, no JavaScript. You can use it with Python or R. Datashader, which is an advanced graphics pipeline system for creating meaningful representations of large amounts of data. And finally, Dask, which makes it very easy for data scientists to use large-scale data using a parallel computing framework that abstracts array and data frame data structures. So we'll see an example on how easy it is for a data scientist to go from using a single laptop using pandas to like moving to a distributed environment using multiple data frames without having an impact on your workflow. So let's take a look at Jupyter Notebooks. For those of you who are not familiar with Jupyter Notebooks, it's a web application that allows to create and share documents that contain both live code as well as explanatory text. And those explanatory text and live code can also include things like equations or interactive visualizations. So now we have a way to tell the story at the same time that we're actually coding our programs or our machine learning models. This is very useful for presentations and sharing insights with decision makers, as you can also, as we'll say, convert to a slide deck. So once you have Anaconda, it's very easy to get the Jupyter Notebook running. You just need to type Jupyter Notebook in your command line. Or you can also, by using Navigator user interface, click on the Launch the Jupyter Notebook app. So as I mentioned, like an effort that Team Analytics is working on is the next generation of notebook presentation. And this is this Jupyter Lab effort, which is also an interactive development environment that's very customizable. So you can have multiple notebooks. You can look at your file directory. At the same time, you can have an interactive Python interpreter. You can have a terminal open, and you can manage that and customize it to fit your workflow needs. So as I mentioned before, with the Jupyter Notebook, it's very easy to switch from this notebook presentation style into a slide deck and a slideshow. So from text, code, visualizations directly to slides. So you definitely know you have a trace on like how you got those results. That is actually the results of executable code. As part of our work with Jupyter, we've also creating other Jupyter extensions like NB Present, which allows you to also customize those slide decks into your own themes and manage the layout of those slides components. So that now you not only can directly transform a notebook into a slideshow presentation, but now you can also edit those slides within the same interface. As I mentioned earlier, managing your environment is very important to assure reproducibility of the code that you're executing. You probably need a specific version of Python. Maybe you require specific versions of different packages. We also have a Jupyter extension, which allows you to do all of that directly through the Jupyter Notebook user interface. So there's two, as an example, of two extensions. We have the NB Conda kernel and the NB Conda. What the NB kernel does is uses the kernel, like when you want to create a new notebook, you can actually select what Python or R interpreter version you want to use from what environment directly from the create new notebook. You can also manage the Conda environment and the Conda packages that exist in that environment through a tab that's added to the NB Conda extension. And so that creates another tab in the notebook where you can see all the Conda environments that you currently have. And when you click to one, also see what are the available packages and whether you want to update any of them, etc. So a full management of your environment and your computations throughout one interface, which is the Jupyter Notebook. I mentioned earlier, but just like so you have an example of, it does support the Jupyter system and the Anaconda distribution, support both Python and R. And here's an example. Jupyter now has over 80 different kernels available for different languages. Two of them are the Python kernel and the R kernel, but it also has support for many other languages. So for example, this is an example of using R with a notebook. You can see on the top right corner, there's the R logo instead of the Python one to indicate that this is running an R. This is an R notebook. So here you can also build predictive models with R as well. And you can see now that you can directly type R in the inside the notebook and get a library like ggplot, load data, and fit a linear model that's available through an R package. It's very easy to get started. You can just add the R channel through Conda. Now you can install the R essentials. When you install the R essentials and open the Jupyter Notebook, you're going to see the R kernel available for you in the Jupyter interface. Another project we're working on and that's already available for people to use, it's called Bokeh, and it's an interactive visualization framework that targets web browser for presentation, but requires no JavaScript or web technologies knowledge. You can write this interactive visualizations in Python or Scala or Lua. It's very easy to embed in existing web applications, and you can also have more advanced server-based apps where you can, data can be updated as your users navigate through the UI. For example, this example that I show here on the movie database, as people select, minimal number of reviews or genre or dollars at box office, that actually goes and queries an SQL database and comes back with the updated results. You can see this demo and many others in the website at the bokeh.org. There's a gallery, and you can take a look at all the possibilities. You can see that to generate this movie interactive visualization requires less than 100 lines of Python code. So it's very approachable for even like a beginner. Here's an example of a clustering visualization that what actually does is when the user selects out of the drop-down menu an algorithm that goes and runs a scikit-learn machine learning algorithm and comes back with the result to the visualization. So now people like business analysts or people who are not actually writing the algorithms or the predictive models, they can actually have an intuition on what's like the best model to fit for a particular data set they have. As I mentioned, the gallery with the survey app examples are available in the Bokeh documentation. As we're working also in Bokeh, a project that emerged from that is called Datashader, and it targets how to automate the process of generating plots without some of the default pitfalls that we encounter. And here are two examples if you want a more extended description of all the plotting pitfalls that exist. You can see the notebook on Anaconda Cloud, or we also have a very extensive white paper that's available through our Continuum website. So just like to mention two examples. These are two exact distributions. In the first, the overplotting that you can see in blue and red. You can see that's like depending on how the plotting library or system that you're working with plots the order of the plot, it might seem that there's more density of one distribution than the other one. For example, in C, you may perceive that there are more blue points than red points, and the opposite for D, while the two have the exact same number of points. Another example of plotting pitfalls is the second line, where we have also two exact distributions, and depending on how much, by doing undersampling, depending on how many points you select and the size of those dots, you get four very different representations of your underlying data. So Datashader automates a lot of the variable selection to select what is the best parameter to use to display the information in the best possible way. And so it provides this automatic pipeline, almost parameter-free, to visualize data sets and automatically get the insights you want from your data in a visual way, but that is also significant. And it's not just biased by the plotting library that you choose and the default parameters that were used. It allows a lot of extensive customization throughout the pipeline, and it supports automatic downsampling and also re-rendering through the use of Bokeh and the Jupyter Notebook. It handles a large data sets because it's also used to our other open source technologies like Dask and Numba. And you can see, that's the GitHub URL to see the project. And just I'm going to show a few examples. For example, here in the right, we have the New York Census data set classified by race, by a categorical variable. So you can see out of the box, very needed distinguish on how the segregation of different neighborhoods occurs. So blue in this case is white. We have green is black communities, red is Asian, and then purple is Latino. So you can see in the central park, very clear. If you're familiar with the area, you can also see Chinatown, very clearly red. So all these patterns, show off from data with very few lines of Python code. Another example by using Datashader are the U.S. Census data and the distribution of population in the United States. And the other one is the New York City taxi data set. And another powerful thing about Datashader is that you can also visually query data. For example, here we can see where we've asked Datashader to plot in color blue if there are more drop-offs than pickups, and to color red if there are more pickups than drop-offs. So you can very clearly see what are the trips that people are getting picked up and where are people being dropped off. And if you notice, the large avenues, vertical ones, are the ones where people get picked up, while people get dropped off in the side streets. So those patterns that might be very difficult to observe through a table of data now become very obvious with very few lines of Python code. You can see a lot of more examples, more of those notebooks on how these different plots were generated through the URL that shows in the screen. Another of the problems we've mentioned on challenges the organization face is how to move data scientists to use larger amounts of data. And so we've developed Dask, which is also a Python library that's being developed here at Continuum that makes it very simple for data scientists to move from using, just maybe a 1 month CSV file with a pandas to maybe, using things that maybe don't fit in the memory of the laptop or compute machine that you're using, to using large amounts of data that are distributed in a cluster. So how does it make that? So with very minimal code, from what you're used to in using your memory constraint data sets with using something like pandas, with very few tweaks, now you get access to managing data that is scalable times more larger. So from things that fit in your in your disk but not in your memory to using a distributed environment. And for the distributed environment, we have our own distributed computing library called Distributed that is very easy to stand. We also have a lot of set up scripts with EC2, etc., where you can very easily stand up those different resources. And it also comes with a nice web interface that allows you to track information on the state of your network, the different processes that you're executing, any performance issues, and debug failures that might be a little bit complex in distributed environments. So just a couple of slides on how we solve. These are problems that we've solved for the entire community through our open source community innovation program. But we also solve problems for our enterprise customers, which care very much about security and governance of the data science process that we've mentioned earlier. So just a quick look to the Anaconda Platform stack. We have the Anaconda distributed at its core, which is the open source and free that you can download today from Continuum.io. Then we have the Anaconda repository, where people can upload their data science assets, Accelerate to get high-performance computing, Scale to be able to manage distributed environments, Anaconda Enterprise Notebooks that allows for data science collaboration, and Anaconda Mosaic for a nice user interface for exploring heterogeneous data sets. And then we have a final project that's called Anaconda Fusion that allows to expose those data science assets to business analysts using Microsoft Excel. So just a quick look at the different interfaces. You can see the Anaconda repository. You can upload different packages, notebooks, environments. In Anaconda Enterprise Notebooks, You can see different projects where you can collaborate with other teammates. We have search and diff for notebooks, revision control, etc. You can manage contributors to your projects. We have Anaconda Mosaic, which allows for explore and visualization of different types of data sets through a UI where you can group by or merge, concatenate, and do all these different transformations from your user from an interface. And then finally, you can see the Anaconda Fusion, which adds in this functionality to Microsoft Excel, where you can input data directly from Excel to functionality that's been written in a notebook, and then output back those results into Excel, and also get interactive visualizations in Bokeh into your spreadsheet directly. So I think I've left 15 minutes at the end for some questions. So this is the last slide. So let's just for a moment revisit what the challenges that we mentioned earlier on, that organizations are facing in embracing open data science. So how we manage reproducible data science environments, how we distribute data science assets, get diverse data scientists to collaborate effectively, enable data science to easily leverage big data technologies, deploy data science assets, and share insights with decision makers. So we've solved those problems both for community members and also for our enterprise customers. So for example, how we manage reproducible data science environments, well, with Conda and Conda environments, open source community members can do that. Also, if you're an enterprise customer and you need to do that behind a firewall, then you can use Anaconda Enterprise Notebooks to do so. How we distribute data science assets? Well, by using the standard, if you adopt Anaconda and you share notebooks, and if you share visualization, etc., in the community, everyone can manage and get that same environment, and that's kind of the standard that can be adopted. In the enterprise level, by using Anaconda repository, you allow people to distribute, not only distribute, but also manage access to notebooks, environments, and software packages, and also build your own. How we get diverse data scientists to collaborate effectively? Well, by adopting the Anaconda distribution, which allows support for not only Python but also R, connects to other, has kernels for things like SAS, if that's something that you have in your enterprise, etc. Now you can adopt also, all those languages, make one platform for all your data scientist needs. We enable data scientists to easily leverage big data technologies through the Dask project that I mentioned earlier, where it's very trivial to go from using one small data set in your laptop as you're used to using several files that you might have in an HDFS cluster in Hadoop. On the enterprise side, we offer Anaconda Scale, which provisions and manages clusters for you and for your enterprise team. To deploy data science assets into production applications, that's in the community we've built Conda Capsule to write that specification, and in our platform you can deploy those capsules into production environments. We currently have it running in Anaconda Cloud, so if you subscribe to Anaconda Cloud, which for public files it's free, you can already see how the capsule process works. Finally, how we share insights with decision makers. Well, here in the community we've done things like the Jupyter Lab, the Jupyter Envy Present, to make it very easy for decision makers to see a slide deck presentation of the results of your models. And in terms of enterprise, we're working on things like a Mosaic and Fusion, which allows this business analyst and manager who are not familiar with the technical or don't have the technical skills to do machine learning or predictive modeling to use directly those in like either a very nice simple UI to transform data or through an interface they're already familiar with, like Microsoft Excel. So you can learn more about Anaconda and all these different projects that I've mentioned, both the open source and also the paid platform, through the resources that we have in our website. We have white papers, webinars, presentations, and videos, everything open and free to access. So thank you very much. This is my email. If you have any enterprise question, you can also email sales@continuum.io, and my Twitter handle if you have any further questions as well. And I think we have some Q&A.
We have lots of Q&A. Thanks, Christine. That was a great presentation. Now let's move on to Q&A. You can always ask your questions in the Q&A box here, and we'll do our best to get to all of them. Our first question is, how can you do version control, like as an investigation proceeds, to recover earlier analysis, or to enable collaborative work by multiple analysts? Christine?
Right, that's a great question. So version control, there's different ways. So for example, you can adopt traditional version control systems like Git or GitHub. We also integrate, the Anaconda platform integrates well with those systems. So definitely Git has been like the de facto version control system that we've seen used. Another thing is that you not only need Git to do version control of the code you're writing, but you also need to manage the environment. So, that's why Conda environments and the Conda capsule and this concept of reproducibility is very important. Is like because you need to know what packages, if the code you're writing runs on like Python 2.7 or 3.5, or there's a specific version of pandas that you need to run that piece of code that you've written. So I would say that for version control, like things like Git, but then for environment management and reproducibility, that's where Conda and Conda environments can help you.
Great. Our next question comes from Mary, who asks, is there anything in the Anaconda distribution for unstructured text analysis, like text mining, entity extraction, and classification?
Yeah, that's a great question. So yeah, there are packages in the Anaconda distribution, and there are some packages that can come directly by the installer, or that you can install via, you can extend the Anaconda distribution. So if there are 120 packages that come the installer, there are 600 more that you can easily install by typing Conda install. And then there's a lot more that can be installed through the Conda Forge community channel. For your specific question on unstructured text analysis, like for text mining, text entity extraction, classification, there are a lot of open source projects that are available through Anaconda distribution or Conda install, like NLTK, Spacey, there's a library called Pattern. So if you go to docs.continuum.io, you can find a section on the Anaconda distribution that has a full list of all the packages that come both by default in the installer, but also that are accessible through the Conda install command. From there, you can look text mining, so you might find others that are not only NLTK or Pattern or Spacey. So I would recommend that if those don't fulfill your needs, you can try that page, docs.continuum.io, in the Anaconda section with all, and you have a link to each of those different packages and get the information of what APIs they provide, what functionality, etc.
Great. Our next question is, how does Anaconda work with Spark on a cluster?
So that's a great question, and that's probably is another full webinar to just like navigate all the different architectures and possibilities. We do have an existing webinar that's available for like on demand on our website that you can watch as an Anaconda for in a distributed environment. So you can watch that to get like a full spectrum on both how does the free Anaconda distribution versus like the Anaconda Enterprise, what functionality they give you to run Spark on a cluster. So Anaconda Scale, which is a part of the our enterprise offerings, has a 4-node free tier. So you can easily get started if you navigate through those docs on one, getting, it's going to help you, one, in get your cluster up and running, both if you have bare metal or a cloud resources like AWS. So you can spin up that cluster, provision Anaconda in all your nodes, and then open a Jupyter notebook that can connect to that cluster that's connected to that you've set up. And from that notebook, you can now type any Spark code that you need. So this is just like a very, and then you can combine, we have some examples in the docs in the scale, if you go into the scale docs, of using things like NLTK with Spark for doing text, like as someone mentioned earlier, for doing natural language processing and like text analysis with both combining some other packages that exist in the Python ecosystem plus Spark on a cluster. So I would definitely recommend going through the scale docs to like see that tutorial of how to get started, and then watch the webinar for more details. But that was like a quick minute run through of where to get started.
Great. Our next question comes from Twitter. What methodologies do you use for designing and implementing interactive visualizations for large data sets?
Right. So I think the combination of using Datashader and Bokeh is your first start. So by combining the both, you can get the easiness of doing Datashader and getting like those parameters adjusted to show, effectively the underlying patterns of your data. While at the same time getting the interactive that Bokeh gives you of like zooming out, and getting those widgets to perform any type of computation that you want on your data set. So again, I would recommend further looking into those two technologies that we have, and any resources you find on those would be useful. Again, that's probably another entire webinar that we could do on large interactive data visualizations.
Indeed. So we're coming up on the hour here, so I'm going to try to aggregate some questions together, if that's okay. We have a number of questions about R and how Anaconda works with R. How can we relate to Anaconda, R to Anaconda? Is RStudio really different than Anaconda? How do our Anaconda and RStudio work together? Can we share data between our data frames and Panda's data frames? So maybe talk a little bit about kind of Anaconda and R and how that all fits together.
Yeah, those are great questions. So to start, you can Conda install, the fastest way to get started is by installing R Essentials. R Essentials comes with R and a bunch of packages for data science, for using data science in R. Once you get R Essentials, you can start Jupyter Notebook with the R kernel by just launching Jupyter Notebook from your command line or through Navigator. You'll come now with a Jupyter interface that has an R kernel. Now you can start typing any type of R code that you want. And it's very easy to add any additional R packages that might not be included in R Essentials. There is in our docs a specific page in the Anaconda section that's called Anaconda for R users. So you can see all the different resources that we offer for that community. On this question on how to use RStudio and with Anaconda, you can definitely point your RStudio to the R interpreter that you want, and that can be one that is under your Anaconda environment. And by the question on how we can share our data frames between R and Python, there's also a package called rpy2 that helps with that. And so I would recommend looking at the rpy2 functionality there.
Great. Now we're coming up on the hour, so we'll do one more, and this is another one of my attempts to aggregate questions together. Thank you for the wonderful session. I'm new, and I want to be a data science, and since data science involves more technologies like statistics and programming and machine learning, can you let me know where I can get started and how I can proceed further to be a successful data siguentist or data engineer one day?
That's great. I think there's a lot of existing content. One of the questions depends on whether you want to self-serve, or if you're willing to go through some type of master's program or boot camp that also exists in the marketplace, right? So if it's a self-serve questions, I would recommend there's first going through the technologies and getting familiar with those. I think we have a lot of good resources in our Continuum website to do that, both in resources, there's a lot of talks, and then from a lot of conferences that we either sponsor or speak at, like PyData, SciPy, PyCon, EuroPython, Data Science Summit, all of those publish all the slides and recordings online. So there's tons of materials of very high quality content from existing data scientists that share their work and share their processes online. So they all have their own kind of YouTube accounts. So by Googling PyData, SciPy, etc., you can get, I think by now it's probably lifetime recordings of data science content that you can get for free. So I would recommend that a place to start. And then of course, if you want some more guides books, etc., then there's also plenty of that. But if the question was on free resources, that's where I would start, conferences, videos, and our Continuum resources page.
Cool. Well, thank you so much, Christine. Great answers. All right. Well, I'm afraid we've run out of time today. I'd like to thank Christine again for her informative presentation and insightful answers to the many questions, and a special thanks to each and every one of you for taking the time to attend and participate today. Lots of folks have asked if the webinar was recorded and if the slides will be available. We will absolutely make them available. The webinar was recorded and will be online in a few days at learning.acm.org/webinar. You can find announcements on upcoming webinars and other ACM activities at learning.acm.org and acm.org. Also, please fill out our quick survey where you can suggest future topics or speakers, which you should see on your screen in a moment. You can click on the survey icon in the menu dock if you don't see it on your screen. So on behalf of the ACM, Christine, and myself, thanks again for joining us, and I hope you'll join us in the future. And this concludes our webinar. Thank you so much for joining us, and we look forward to hearing more from you and understanding how you use Anaconda.
Thank you. Bye.